before. Save me, I'm lost. Oh Lord, I've been waiting for you. I'll pay any cost. Save me from being confused.
Good day to everyone who's watching us right now. In today's lesson, we will be discussing integration. Before we get started, let's dive into the objectives of this video. So, before we start with everything, let's first define what's integration, and then moving on, we'll be discussing about basic integration, next, integration by substitution, in, next, after that, integration by parts, and lastly, definite integration. So let's start with what's integration. So in math, integration is a method of adding or summing up the parts to find the whole. It is a reserved process of differentiation where we reduce the function into parts. This method is used to find the summation under a vast scale. So basically, in layman's term, integration is the reverse of everything. So for example, uh, 3 plus 3 is equals to 6. Integration is basically 6 minus 3 is equals to 2. Something like that. Moving on.
Hi, my name is Prince Lim, and now we are going to discuss the basic rules of integration in this part. Now, let's get started. Now, let's say, for example, you want to integrate dx. So the answer here is x plus c. Now, let's say you want to integrate dy. The answer for here is y plus c. And let's say, for example, you want to integrate dt. The answer for here is t plus c. Now, this is the variable of integration. Make sure to always add the variable based on what you see here. Now, now let's say, for example, now you want to get the integration of a constant. So let's write the formula here. Kx plus subconstant c. So always remember that the variable of integration is always here. So based on what you see here, you have to add it here. Now let's add, for example, 5 dx is equal to 5x plus c. And now that's, for example, 12 dx is equal to 12x plus c. Now, another rule you have to remember is the power rule. Now let's say x raised to n dx is equal to x raised to n plus 1 divided by n plus 1 plus some constant c. Now, this is the formula for the power rule of the integration. So, I will give some examples to you that so you will understand more. So let's say we have x raised to 4 dx. So it is equal to x raised to 4 plus 1 divided by 4 plus 1 plus c is equal to x raised to 5 over 5 plus c, or which we can write 1 over 5 x raised to 5 plus c. There we go. There we have it. Now, I will give some more examples for you to understand more. So let's say the integral of x cubed dx is equal to x raised to 3 plus 1 divided by 3 plus 1 plus some constant c. Now, this is pretty easy. X plus 4 divided by 4 plus c. So, there we have the answer. And here another example for you guys to understand more. 10x raised to 2 dx is equal to, what we're gonna do again, 10x raised to 2 plus 1 raised to, divided by, 2 plus 1 plus c is equal to 10x raised to 3 over 3 plus c, or which we can write was 10 over 3 x cubed plus c. I will give you another example. Now let's say 1 divided by x squared dx. So what are we gonna do here? When we have a function right here, we need to rewrite first. Let's rewrite first. X raised to negative 2 dx. Then now we use the power rule. Let's say x raised to negative 2 plus 1 divided by negative 2 plus 1 plus c. Now we will get negative 1 and negative 1 plus c, or which we can write negative 1 over x plus c. Now remember guys, if you have a rational function like this, always rewrite then use the power rule. Next for us is the trigonometric functions. Now it has 6. So the first one is antiderivative of cosine x dx is equal to sine x plus c. You have to memorize this guys for it to be easy. Now next is sine x dx is equal to negative cosine x plus c. Next in line is secant square x dx is equal to tan x plus c. Then secant x tan x dx is equal to secant x plus c. Last two, cosecant squared x dx is equal to negative cotangent x plus c. Then lastly, cosecant x cotangent x dx is equal to negative cosecant x plus c. Now remember guys, you have to remember all these trigonometric functions for you to easily solve all the integrations of trigonometry. I'll give you an example of a integration of trigonometry. So let's say the antiderivative of 8 cosine x plus 3 sine x is equal to dx, is equal to, first we talked about the derivative of cosine x, which is equals to 8 times sine x plus the derivative of 3 is equal to negative cosine x. Don't forget the plus c. Then multiply them. 8 sine x minus 3 cosine x plus c. There we go. We have the answer. That's why it is important that you memorize all the trigonometric functions and their antiderivatives. Let us start with the exponential functions. Let us try to integrate exponential functions, whereas the antiderivative of e to the u dx is equal to e to the u o divided by u prime plus c. This will only work if the u is linear or u prime is a constant. There. So I'm gonna give some examples for you guys to understand. So let's say e raised to 3x dx is equal to e is still the same, 3x, then the derivative of 3x, which is 3 plus c. The denominator is a constant, so this will be the right answer. And another example for you guys to understand more is e to raised to 7x plus 3 dx. Don't forget the dx. And so now let's write e raised to 7x plus 3, then the derivative of 7x plus 3, which is 7 plus c. Again, the denominator is constant, so the answer is correct. We are going to start with the logarithmic function. Now, let's say you want to integrate the logarithmic function. 1 divided by u dx is equal to the natural log u and u prime plus c. Again, u has to be linear and u prime has to be a constant. There we go. And I will give some examples for you guys to understand again. Let's say 1 over x. Let's go to with the basics. Let's say natural log of x over derivative of x is 1 plus c. There we go. And for another one, let's try a much more complicated one, which is say 5x minus 3, which is dx. Don't forget the dx equals to natural log just 5x minus 3. What is the derivative of 5x minus 3? That's correct. It is 5 plus c. There we go. And now, that's all we have it. Thank you for listening, and I hope you understand and learned something well. Bye-bye.
Hello and good morning. For today's video, I would be discussing what is the formula for U substitution, also known as integration by substitution. What is integration by substitution? This is a method for finding integrals using the fundamental theorem of calculus, often requires finding an antiderivative. For these and other reasons, integration by substitution is an important tool in mathematics. It is the counterpart to the chain rule of differentiation. This method is intimately related to the chain rule for differentiation. In this method, the function is replaced by u and then integrate according to the fundamental integration formula. After integration, substitute the real function instead of u. For our first example, we want to find the antiderivative of 4x times x squared plus 5 raised to 3. First, we need to define two things. We need to find the u variable and the du. Whatever you select u to be, du has to be always a derivative. If we make x squared plus 5 the u, the du is going to be 2x, which can cancel the 4x. That would make our u x squared plus 5, and our du would be 2x times dx. Now, we need to divide both sides by 2x. The 2x would be cancelled, and our dx would be equal to du over 2x. Our next step would be the substitution. What we need to do is replace the x squared plus 5 with u and dx by du over 2x. So now we will have 4x times u raised to 3 times du over 2x. We can cancel the 4x by dividing 4x to 2x. That would give us 2 times the antiderivative of u raised to 3. Using the power rule, it's going to be 2 times u raised to the 4 over 4 plus c. Now 2 over 4 is 1/2, so it's gonna be 1/2 u raised to 4 plus c. The last thing we need to do now is substitute the u with x squared plus 5. So the answer is 1/2 times x squared plus 5 raised to 4 plus c. That would be all for our first example.
Hello, good day. My name is Natalie Rossi Binuada, and the topic I will be representing for today will be integration by parts. First off, we are going to show the formula to be used in order to get our answers. The formula, or the general form, is integration of u dv minus integration of v du. U is the constant, and we also get the derivative of the constant, v function, and derivative of the v function. Alright, for our first example, the given is integral of x times e raised to x dx. Our first step is finding the values of u, dv, v, and du in order to use the given formula. U is equals to x. dv is chosen by adding the remaining function of the equation. Afterwards, we have to integrate to both sides to get the value of v, which is e raised to x dx. And lastly, our du is the derivative of the function. Du over dx is equals to 1, and then du over dx can be multiplied to the right side. Therefore, the final answer for du is equals to dx. Now that we have our values, it's time to find the answer. U multiplied by v is equals to x e raised to x, while integral v times du is equals to negative integral e raised to x dx. Before we determine the final answer, we have to integrate the function e raised to x first. Therefore, the answer will be x e raised to x minus e raised to x plus c. C means constant, and we should not forget to add this on our final example because it is really important. However, we're not finished yet. As you can see, we can actually still simplify the equation by factoring. So, our final answer this time will be e raised to x, open parentheses, x minus 1, close parentheses, plus c. Okay, our second example is the integral of x sine x dx. Just like the previous number, the first step is finding the values of u, dv, v, and du. We will choose x as our u, dv will be sine x dx, and to get our v, we integrate both sides of dv. The integral of sine x dx is negative cosine x. And the u is the same as our last example. That means the du for this number will also be the same. Du is equals to dx. We use the formula to find our answer, multiply u and v, then the integral of v times du. All of that will be equal to x times negative cosine x minus the integral of negative
cos sine x dx. We integrate the second function, which is the integral of negative cos sine x dx, and get our final answer, which is the negative cos sine x plus sine x and plus c.
So, moving on to definite integration, based on the name itself, definite, so meaning the answer of this lesson is that it has a definite number or a specific number or a constant. So, in order for us to solve for the definite integration, we have this formula of the integration of fx dx equals to fb minus fa. In order for me to explain this formula further, let's start with the first example. As you can see here in the integral symbol, there are numbers. So, based on this formula, b is equals to 4 and a is equals to 3. So later on, once we've integrated x cubed, we can substitute 4 to x. So that's the reason why there's fb minus fa here. So we will follow this formula later on once we've integrated x cubed. So in order for us to integrate this, we have to follow the formula of x and my plus 1 over n plus 1. So when we follow this formula, we'll get the answer of x raised to 4 over 4. Since n is equals to 3 and you have to add 1 to it, it will be equal to 4. And since underneath the division bar is the same thing, that's the reason why 4 is underneath it. So this is the reason why this is the answer. So after finding the after integrating x cubed, we can now substitute 4 to x and later on 3 to x. So if we follow this formula, fb minus fa will get 4 raised to 4 over 4 minus 3 raised to 4 over 4. So we can further simplify this and we'll get the answer of 64 minus 20.95. And when we um, subtract this, we'll get the answer of 84.25 or 337 over 4. So moving on to the next example. In order for you to answer this, let us first um, not look at the coefficients of each function since it's a little bit confusing. So we can follow this equation with x cubed, x squared, and x. So when we integrate it, we'll get the answer of 8x raised to 4 over 4 plus 3x cubed over 3 plus 3x squared over 2. Now we can further simplify this since 8 can be divided into 4 and 3 can be divided to 3 and 6 can be divided into 2. So the answer will be 2x raised to 4 plus x squared plus 3x squared. Now we can substitute 3 to x to the x's that we can see here and 2 as well later on. And we'll get the answer of 2 times 3 raised to 4 plus 3 raised to 2 plus 3 times 3 raised to 2 minus 2 times 2 raised to 4 plus 2 raised to 2 plus 3 times 2 raised to 2. Now we can further simplify this and we can get the answer of 188 minus 48. Now then, and we can further simplify it and we can get the answer of 150. Now, moving on to the third example, we have 2x plus 3 quantities squared dx. So in order for us to integrate this properly, we first have to expand 2x plus 3 since there's a squared here. So we will have the answer of 4x squared plus 12x plus 9 once we've expanded it. Now we can further integrate it. Now, once we've integrated it, we'll have this answer 4x cubed plus 3 plus 12x squared over 2 plus 9x. So as you can see here, you can 12 is divisible by 2, but I've already substituted it directly. So you can also do that, just like in this example. 4 times 3 cubed over 3 plus 12 times 3 raised to 2 over 2 plus 9 times 3 minus 4 times negative 1 raised to 3 over 3 plus 12 times negative 1 raised to 2 over 2 plus 9 times negative 1, and we have the answer of 117 minus this is negative, sorry, this is negative 13 over 3, and because of that we'll have the answer of 364 over 3.
What I'm looking for.